When dealing with an accessory apartment and its electrical load, it is crucial to ensure the existing service is adequate to handle the combined demand. In a situation where a customer has an in-law apartment above their garage, which is being reclassified as an accessory apartment and put on its own meter, the existing service needs careful evaluation. The initial assessment reveals a 2,000 square foot main house with a calculated load of approximately 140 amps, supplied by a 200 amp underground service using 4/0 aluminum conductors. The new accessory apartment has an additional calculated load of around 89 amps. The question arises whether the existing 4/0 aluminum service lateral conductors are sufficient for the combined load. It is important to understand that the 4/0 aluminum service lateral conductors are not large enough to supply both the main house and the accessory apartment adequately. The total calculated load for the main house and the apartment amounts to 140 amps plus 89 amps, which equals 229 amps. This exceeds the ampacity of the 4/0 aluminum conductors, which is rated for 200 amps. The National Electrical Code, or NEC, provides guidelines for calculating service amperage for dwelling units under Article 220. These calculations involve multiplying the square footage of the dwelling unit by a specific load factor. For the first 1,000 square feet, a load factor of 3 volt-amps per square foot is applied, while each additional square foot is calculated at 1 volt-amp per square foot. Applying this to the main house, which is 2,000 square feet, the calculated load is 2,000 square feet multiplied by 3 volt-amps per square foot, totaling 6,000 volt-amps. For the accessory apartment, let's assume it is 500 square feet, though this needs to be accurately determined on site. The calculated load for the accessory apartment would be 500 square feet multiplied by 1 volt-amp per square foot, resulting in 500 volt-amps. The total calculated load for both the main house and the accessory apartment would be 6,000 volt-amps plus 500 volt-amps, totaling 6,500 volt-amps. Converting this to amps, we divide 6,500 volt-amps by 240 volts, which equals approximately 27.1 amps. It is crucial to recognize that this 27.1 amps figure represents a calculated load based on general assumptions of square footage and load factors. It does not account for various appliances or equipment that may have significant amp draws. Therefore, relying solely on this number would be inappropriate for service sizing. Despite this calculation, it is always recommended to install a service that exceeds the calculated load to accommodate future expansion and ensure safe operation. In this specific scenario, the most prudent course of action is to install a new 200 amp service utilizing 4/0 copper service lateral conductors. This upgrade will provide ample capacity for both the main house and the accessory apartment while also allowing for any potential increases in electrical demand in the future. The use of copper conductors, while more expensive, offers better conductivity and corrosion resistance compared to aluminum. When planning the upgrade, several key factors must be considered. Firstly, a thorough review of the National Electrical Code, specifically Article 220, is essential to accurately calculate the service load for both the main house and the accessory apartment. Secondly, the electrical inspector should always be consulted to ensure compliance with local regulations and requirements. Thirdly, the proper selection and installation of all electrical components, including the meter socket, disconnects, and conductors, are critical for safe and reliable operation. Furthermore, remember that the calculations provided offer just a glimpse of what is needed. Actual load calculations according to Article 220 of the NEC involve a more in-depth analysis of the specific appliances and equipment that will be used in both the main house and the accessory apartment. This includes considering the amperage ratings of all lighting fixtures, outlets, heating and cooling systems, and other electrical devices. In addition, demand factors may be applied to certain loads, recognizing that not all electrical devices will be operating at their maximum capacity simultaneously. For example, the NEC allows for a demand factor of less than 100% for electric ranges, clothes dryers, and other high-demand appliances. This means that the calculated load for these appliances can be reduced by a certain percentage based on the assumption that they will not all be used at the same time. Moreover, when selecting the appropriate size of conductors for the new service, it is crucial to consider not only the ampacity of the conductors, but also their voltage drop characteristics. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a conductor over a certain distance. Excessive voltage drop can cause appliances to operate inefficiently or even fail prematurely. The NEC provides guidelines for minimizing voltage drop in branch circuits and feeders. It is recommended to limit voltage drop to no more than 3% in branch circuits and no more than 5% in feeders. To minimize voltage drop, it may be necessary to increase the size of the conductors beyond what is required for ampacity alone. Also, the installation of the new service must comply with all applicable codes and regulations. This includes obtaining the necessary permits, following proper grounding and bonding procedures, and ensuring that all electrical connections are made securely and properly. The electrical inspector will typically conduct a thorough inspection of the installation to verify that it meets all requirements. Also, the installation must comply with local utility requirements as well. The utility company may have specific requirements for the location of the meter, the type of meter socket that is used, and the method of connecting to the utility grid. It is important to contact the utility company early in the planning process to determine their requirements and ensure that the installation is designed accordingly. Lastly, it is important to consider the impact of the new service on the existing electrical system. If the existing service panel is already full, it may be necessary to install a new subpanel to accommodate the additional circuits for the accessory apartment. The subpanel must be properly sized to handle the load of the circuits that it will be serving. The subpanel must also be properly grounded and bonded to the existing electrical system. The existing grounding electrode system must be adequate for the new service. The grounding electrode system consists of the grounding electrode conductor, the grounding electrodes, and the bonding jumpers. The grounding electrode conductor connects the service equipment to the grounding electrodes. The grounding electrodes are typically metal rods or plates that are buried in the ground. The bonding jumpers connect the various metal parts of the electrical system together, such as the service panel, the meter socket, and the grounding electrodes. The grounding electrode system must be properly sized and installed to provide a low impedance path for fault current to flow back to the source. This will help to protect people and equipment from electrical shock in the event of a fault. Also, the service should be adequately protected from overcurrent. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or a short circuit. The overcurrent protection devices must be properly sized to protect the conductors and equipment that they are serving. The overcurrent protection devices must also be properly coordinated to ensure that the fault is cleared as quickly as possible. In addition to the technical considerations discussed above, it is also important to consider the aesthetic aspects of the new service. The new service should be installed in a location that is both accessible and aesthetically pleasing. The service should be installed in a manner that does not detract from the appearance of the property. The service should also be installed in a manner that is safe and does not create a hazard for people or animals. It is also important to consider the environmental impact of the new service. The installation of the new service should be done in a manner that minimizes its impact on the environment. This may involve using energy-efficient equipment, recycling materials, and minimizing waste. Here is a list of key steps in operating the electrical service. Firstly, perform a thorough load calculation. Secondly, consult with the local electrical inspector. Thirdly, obtain the necessary permits. Fourthly, select the appropriate size of conductors. Fifthly, install the new service according to code. Sixthly, properly ground and bond the system. Seventhly, protect the service from overcurrent. Eighthly, coordinate with the utility company. Ninthly, inspect the installation. Tenthly, document all work. Remember to prioritize safety and compliance with electrical codes. It is always recommended to consult with a qualified electrician.